And after getting a prestigious position as a professor in National Institute of Technology, Gujarat, Dr. Bhaskar is fully concentrating on research area, especially in the field of structural engineering. And he has produced n number of PhD research scholars from NIT Trichy. And also he has produced more than 100 postgraduate, that is ME, MTech, structural engineering students from NIT Trichy. And also he has visited almost all the countries. If I list out the countries, the time is not permitting. Many more foreign countries like Germany, Japan, Singapore, Malaysia, all countries he has visited. And Dr. Bhaskar is doing n number of AICT, UGC funded projects. That is his achievement. That is his achievement. Dr. Bhaskar sir, we are so fortunate to have you today. And our Sion Engineering College, the Civil Engineering Department, the students and the faculties are delighted to see your smiling face. Once again, on behalf of the management of the Sion Engineering College, wholeheartedly I welcome you, sir. Now the section is to you. You can present the sections 30 to 40 minutes, sir. Then the next speaker will join, that is Nisha Radhakrishnan from your same institution. Madam is also joining after you, sir. Welcome, sir. Please take over the section.
Yeah, very good morning to all of you. Yeah, I am Bhaskar, professor in the Department of Civil Engineering, National Institute of Technology, Tiruchirappalli. And first of all, I wish to place my sincere thanks to Dr. Bhagavati Perumal, who known to me for more than 20 years and a good friend of mine, very sincere, hard worker, highly ethical and a professional teaching faculty. He is a very, very genuine person, and I'm very happy to share some of my information in this particular conference, which is organized by Dr. Bhagavati Perumal. So when he approached me regarding a lecture on this conference, I immediately accepted because two reasons. One is to honor my friendship. The other one is to share the experiences. The two options. Okay. And, it is disseminating knowledge from one end to the other end. What is the purpose of conferences? It is disseminating the knowledge from one end to the other end. That's all. Coming to this particular topic, I'm not going to talk about a particular problem and how the research is carried out on a particular problem. It is not like a PhD presentation, or it is not like a postdoc presentation. It is general. And what are the opportunities available for the young budding engineers? Okay, with that objective, I prepared this particular slide. Okay, the primary objective is to convey the different opportunities, different fields of engineering, especially within the structural engineering, and how we can proceed further. Okay, I hope many MTech students and BTech students and faculty members with MTech, the qualifications are attending. Of course, there will be some postdoc, doctorate faculty members also. They can also think about the further research. Okay, so I'm going to discuss various points. Okay, so it is going to be more general. Okay, yeah, this is what I said. Yeah, I thank Dr. Bhagavati Perumal, Professor and Head of Civil Engineering, Sairam Engineering College, and the principal and the management of Sairam Engineering College for conducting this international conference and also giving me an opportunity to talk to you. And before I proceed, I wanted to place this acknowledgement card because this is very, very important. So I hereby acknowledge my PhD supervisor, Professor N. E. Shanmugam, NU Singapore, and Professor J.Y. Richard Liu, NU Singapore, for permitting me to use some of the photos, images, and technical materials in this presentation. This is very, very important acknowledgement. And also, I hereby declare that I have used few photos that are collected from various websites for academic demonstration purposes. Okay, so just to know what is happening worldwide and so on. Okay, there is no commercial part in the use of such a photos. I thankfully acknowledge those websites. So coming to structures. So I hope all are civil engineering fraternity here, and many of you will be working on structural engineering. This is very basic question. Okay, so very fundamental question. What we understand structure. Structure is nothing but a group of elements or members jointed together to support any weight due to human materials or to support any reaction forces arising from certain applied actions. So the group of elements connected together. Okay, so what is the purpose of doing that? To transfer the load from one end to the other. Okay, so that's what we call it as structure. Okay, the structure receives the force from one end and transfer the same to the other end or to the permanent point such as ground. Okay, this is what we call it as structure. Okay, saying that, okay, what are the different forms of structures? Okay, building means it inclusive of everything, but structure is the backbone. It is your skeleton of the body. It is a skeleton of the body. Okay, what are the elements included there? How they are connected? How they are subjected to various forces, and how they are transferring the force from one end to the other end. Okay, so that primary skeletal is called structural system. Okay, so when we say that, so what are the different forms of structural system, historically? So we say hut, then mud houses with unburned bricks, then stone masonry structures, then tiled roof house with the burnt bricks with the mortar. This is the historical development. Okay, burnt brick houses with lime mortar, then brick masonry houses with cement mortar, then masonry structure with reinforced concrete roofs, then framed structures for larger dimensions and heavier loads. Larger dimensions means larger column free spaces, and then without any obstructions. Okay, there we go for framed structure. So in all these things, it is slowly developed throughout the, the years, decades. Okay, for many decades it is developed. Especially in India, the framed structure. Okay, in cities we have seen, almost like 56 years back, but in the rural side and small towns and all, it is only in the last 30 years we can see this kind of buildings. And before that, we always go for load-bearing structures. It's called a masonry structure with reinforced concrete roofs. Okay, so this is the historical development. Okay, so basically it tells you the load transfer mechanism from one end to the other end. Okay, if you say hut, the hut is also having some load bearing. That is what an engineer should understand. Okay, we have the bamboo sticks. The bamboo sticks are placed one over the other and it is tied. That's your structural system. Okay, then the bamboo stick is supported by vertical bamboo sticks. Then without any cladding material over there. That's the structural system, hut. Okay, then they put the coconut leaves or the other leaves. Okay, so they cover that area. So that's called the hut. Okay, so it is also having a structural system. When there is a cyclone or whatever, the structural system will give away. Okay, then what to do? So we should, even for that also, they have some thumb rules. Okay, they won't come to the engineer, but they have the thumb rule. how to RSS. If you closely monitor, people from rural side and village side, if you go into the hut, you can see a lot of bracings, you can see a lot of bow elements, and that will take care of the lateral forces and so on. You can appreciate it. Okay, so it is not a simple, the bamboo element connected together. They do some engineering. So that from there onwards, you should start think, okay, how things are. What is the purpose of doing this? Okay, and when you slowly go, the tiled roof and the burn clay, brick masonry, cement mortar, still we are doing research. Still there are a lot of research in everything. Say for example, brick. We have the country made brick, then we have the kiln brick, then we have the first, classes of bricks, second class brick, first class brick, and then we have now what is it? The new. Sorry to say that, fly ash bricks, and now we have the lightweight blocks, the aerocon blocks. So we are now not leaving anything. The research, different level of research. When we say fly ash, within that fly ash, we have C class fly ash, F class fly ash, and how it can be used. What is the reaction between the cement? So everything falls within this. Everything falls within this particular slide. Okay, so we are working on brick, we are working on cubes, we are working on blocks, we are working on mortar, we are working on cementitious material and how to improve the cementitious material. Then when we come to reinforced concrete slab, we are going with the hollow slabs and fiber reinforced slabs and ferro cement roof slabs. So many technology. Okay, basically this is the scale, the primary element. Okay. Finally, now we are working on framed structures. Okay, framed structure means it can go for larger dimensions and for heavier loads. Okay, now our focus is more on framed structures. Or in rural side, people are still, even in rural side, people are even for small buildings also people are going for a load bearing structure. And load bearing structure is very, very important because if you see the Indian scenario, almost like 80% of the people are staying in the village. Okay, and all are not affordable for framed concrete structures. Still, if you go, any part of India, we can say the load-bearing structures are very popular, and therefore the load-bearing structures are also subjected to a lot of researches. Okay, and masonry wall subjected to in-plane loading, masonry wall subjected to out-of-plane loading. When we say the masonry wall with the different forms of another bond, you have come across Flemish bond, English bond, structure bond, header bond, and which bond is good for seismic activity and how we can improve. And nowadays we are trying to put some small concrete elements within that, okay, in a pocket, and then we are trying to improve. So as an engineer, as a researcher, there are so many opportunities in each and every activity, even what is it called, housing, ordinary housing, load bearing structure. In that load bearing structure, if the roofing plays a major role. Assuming we are building with the concrete, in the ordinary wall, the slab, normally people go for RCC slab and it is heavy. Okay. And now there are so many, when it is heavy means weight. Okay. When it is subjected to seismic load, okay, the seismic forces are proportional to the weight, the mass. Okay. India is divided into 5 zones, and the first zone is meridian. Only 4 zones are right now available in the code as per the code. When we go north side, and major portion of the country is under seismic zone. Even within Tamil Nadu, if you go to Coimbatore and some part of other Tamil Nadu and Kerala side, we have seismic zone 3. Okay, in those places, when the ordinary building, why I am focusing on the ordinary building, it is used by 80% of the Indian population. Okay, so we need a lot of research in that particular domain. Okay, the roof, how we can minimize the mass. What are the other elements we can use? Now people are using the precast channel sections as a roof slab. precast triangular section as a roof slab, precast half sine curves as a roof slab. They stack it and then they put a street concrete. Okay, it's for lightweight applications. Okay, for normal residential buildings, and these are all the olden technology. Now people are going for ferrocement, the box sections, ferrocement channel sections, and now there is a new concept called TRC. Okay, textile reinforced concrete. Okay, so there are so many things happening to optimize even a simple building. Okay, we are always talking about very major issues. Okay, but say even yesterday in the inaugural function, the PT Morgan was talking about uh, depletion of the aggregates. Okay, so we cannot keep on take the aggregate. How long you will keep on take the aggregate? Even the earth will become unbalanced because we are everywhere. We are blasting the mountain and we are breaking into pieces and then we are using it. So we have to optimize so that the utilization of that aggregate will come down. Not only that, I will touch upon that. So there is a scope for research in all the aspects. Okay, so how we can modify the sections so that it can lead to a very lightweight and efficient, and the material utilization will be less and functionally good, and so on. Okay, so this is what in that 80%. And that's a reason why there is a special journal called Journal of Can Build. Okay, construction materials and building, and there are so many journals available for material research. Okay, so so many people are working on the material side. Okay, now coming to the modern construction, okay, which is utilized by 20% of the people, or go to the skyscrapers, it is used by 1% of the population or whatever, but still we are supposed to know what is going on and what is the industrial need at the moment and so on. So what are the opportunities and how we can make use of it, and what is going on, and what are the research opportunity available there, or what are the field opportunity. In that sense, we should know all those things. Okay, so in that sense, if you go focus on types of frames, so we can classify the frames with respect to materials. We can say reinforced concrete frames, we can say steel frames, and steel concrete composite frame. This is the hierarchy. The very first frame structures are made with the reinforced concrete, RCC, we call it as RCC frame. Then we have the steel frame, okay, steel concrete composite frame. And to be frank, in Indian construction scenario, we are still depending on the reinforced concrete frames, and steel we are using. But if you ask any normal person, okay, don't talk about any special people, normal people, public, and those who have a lesser exposure to steel construction, they will always say steel construction means they will go for shed, cycle shed, car shed, industrial shed. Now the industrial building is coming a little bit bigger. So this is what now our Indian mindset will say. Okay, steel means it will be used only for making a A-frame, making trusses, okay, making industrial buildings, making airport structures and so on. Okay, probably single-story building, something like that. But people are not aware of steel framed structures. Okay, steel frames are it is not new. Actually, it is not new. Worldwide, if you take American buildings and all, even 100 years back they have made, okay, steel frames, because there are some advantage. There are some advantage in steel frame construction. I'm going to talk about that. And then the next stage is steel concrete composite. The steel frames as well as steel concrete composite frames, it is widely used in all the developed countries, but in India it is not so, slowly picking up. Okay, that reason also I will tell you now. Okay, let us discuss. These are the major frames. Okay. See now, why I my focus will be on steel frame and steel concrete composite frames. Okay, why I should talk about the steel frames and steel and concrete composite frames? Because in India It is not, now it is upcoming. A lot of developments are going on. And primarily, concrete frames. Okay, I will go one by one. Okay. The steel members will give you a very high strength to weight ratio compared to concrete. Okay. For, you mean the sulfate of the member will be less compared to the strength. Okay. It will give you very, very high strength. For the same strength, if you want to design with RCC, the sulfate of the system will be very heavy. What will happen if it is very heavy? What will happen if it is light? If it is very heavy, the mass associated is high. The inertia forces are high. When the seismic zones are there, and the inertial force will be there. And all the sections are to be designed for very high. The sulfate is more, because of that we have to design very high, very large sections. And column sizes will go up. Then foundation size will go up. Okay, on the other hand, if it is steel, if it is lightweight, okay, and everything will come down, including the foundation forces, including the cost of construction. Okay, so that is the point, high strength to weight ratio. Okay, and then standardized member sizes and the sections. Okay, if you go to steel construction, it will be standardized member. Okay, we have SP6, we have plenty of members. Okay, like that every country is having the standard, Vizag Steel, Jindal Steel, Tata Steel, or everyone is preparing as per the standard sizes. So you can buy and you can assemble. Okay, then the quality, we are not compromising the quality. The element means it is element. Whereas in concrete, a lot of difficulties are there. Okay, every time you have to put a former, and you have to design the mixed design, and you have to arrive the characteristic strength, and you have to pour the concrete, and you have to cure it. There shouldn't be any leak or nothing, and the former should not twist, or former should not get damaged. And if anything happens, the quality of construction will go up. That's a problem. Okay, then here the standardized construction procedure. Okay, you fabricate, you just make the sections, make the holes and plates connected together, you bring it and assemble. That's it. Okay, see, these are all the quality construction we can arrive. So we are not using so far. Why? Because actually, I always used to say, whenever you feel hungry, you will look for food. When you are not hungry, you will not look for food. And also, when you are hungry, whatever the food given to you will be very tasty. If you are not hungry, whatever the 5-star food given to you, you will not feel happy or tasty. That's the thing. Now the demand is there. Previously, this demand was not there. Okay, what are the demands? We have to go for very long spans without any columns. We have to go for very larger loads without any supporting members, columns. Very, very large spans we want. Previously, it was not like that. Okay, we have a standard dimensions. And also now we are thinking about verticals. Okay, in Mumbai and all, already 60-story buildings have come. Okay, even in Chennai, we are going to 30-story buildings. Bangalore, Hyderabad, of course, a lot of high-rise buildings. Okay, previously it was not there, and therefore the requirement is something different. Now, when we go for this kind of construction, and see a lot of issues like whatever I discussed, okay, high strength, weight, and all those things, and also the structural aspects. The steel structures will give you larger strength and will provide large ductility. What do you mean by large strength and large ductility? Okay, for smaller weight, it will give you larger strength that we have discussed in the very first point itself. Larger ductility. What do you mean by ductility? Say, for example, you take 1 foot scale. 1 foot scale. One is made of glass. Other one is made of steel. Other one is made of wood. You place the wood first, glass first, wood second, and steel third. Okay, you apply a load. Okay, fix at the bottom, you apply the load at the top. What will happen? Which one will break easily? The glass plate will break. Why? It is a brittle material. Okay, it is a brittle failure phenomenon. Okay. So it will not, it will take some load, but it will not deform. It will not deflect. That's called the brittle property. Then take the wood. The wood is slightly better than the glass. It will deform to a smaller extent. After that, it will also break. You take the steel ruler, you apply. What will happen? It will keep on bend. It will carry the same load, it will keep on bend. That's called the ductility. Okay. After exceeding the allowable deflection, without losing its strength, it will deform. That's a bottom line, underline, you have to underline. Without losing its strength, it will deform. That's called ductile property. This property you can achieve in steel structures, but in the concrete structures, it is very limited. Okay, so the concrete structures uh, only up to certain height we can go, like 60-story building or whatever. But now nobody is going even for beyond 30-story. Okay, now whatever the skyscraper you see in the, wherever, okay, internet or wherever, so they are all, the main frame is made with the steel. Okay, so this is what the ductility is the primary one. Okay, then convenient to form any complicated geometry, then available in various strength grades. Okay, so for example, we always, as a undergraduate class, we always go with the FE 250 grade. Okay, now people are going FE 350 grade. But if you see your IS code itself, there are more than 10 grades are available. Okay, so we can use. Then apart from that, the steel construction is the green material. What do you mean by green material? Okay, so the depletion of the natural material will be less here. Okay, so for example, you take concrete. You need coarse aggregate, you need fine aggregate, and you need cement, and you need steel. Coarse aggregate from natural resource, fine aggregate from natural resource, and cement is a product from the natural resource. And also, it is from the lime material. We are making cement. Huge manufacturing process, and in each and every process, we are eating away the natural resources. Now there is a big, problem with the river sand. Okay, big problem with the aggregates, and the cement industry also. They are also, their raw material is, from the source. Okay, so that there also the source, issues are coming up nowadays. And when you make the cement, lot of pollution issues, air pollution issues. Okay, and that production itself consume lot of power. Whereas in the opposite side, when you go to, and apart from all, do the construction. The construction site, you have to do a lot of precautionary measures. Okay, then the waste, during construction also, some kind of waste will be there. We don't know where to dump. It's very, very difficult to dump the extra materials. Okay, everything we assume it is granted. Then, after serving its purpose, now we are in that particular stage. That also we have to look into it. After serving its purpose, say for example, 60 years or 70 years or 80 years, if you want to demolish and reconstruct, what will happen? There is a big problem. Where will you dump all the debris? Very, very big question mark. Even people cannot push it into the ocean, because the ocean, the entire ocean is protected by the world, organizations. Okay, we cannot dump anything in the ocean also. Okay, where will you dump? Suppose, your own home, you wanted to reconstruct. Where will you place? It's a very big challenging question. Okay. Recycling is not that's why there is a further research. Okay, recycled aggregates. People are now started working with recycling. That is another domain. Okay, that is to minimize two ideas. One is to reuse the material. The other one is to reduce the the taking out from the original material. Okay, to reduce the depletion of the material. Okay, so with that objective, people are working on the recycled aggregate. But whereas you come to steel, you do construction, Okay, if you want to, you can reuse. You can dismantle and you can reuse. Even after you think it is corroded or whatever, after 100 years it won't work. It can be melted and it can be remolded. Okay, that much amount of steel you need not take from the natural source. You can, once you have the material, you can melt and you can remold and you can add whatever the chemical compositions inside and you can make very stronger steel also. Okay, so that in that sense, okay, we are not depleting that material, but we are reusing the material in many different forms. That's why the steel construction is called green material. Say, for example, in the World Trade Center building, due to terror attack, the two towers are collapsed. Okay, thousands of tons of steel because it is full and full of steel construction. And you mean they will be dumping some? No, it was it was recycled. Very simple. Okay, so that's the advantage. Even here we have one the naval ship Vikrant. They have after its service they sold it and the Bajaj they purchased and then they dismantled and then they made the steel and one particular version of the Bajaj bike Vikrant. They mentioned the name as Vikrant. Vikrant is a strong bike like that. So these are all the things why we are going for steel construction. Okay. Now coming to steel construction, see nowadays the PEB steel buildings. Okay, so it is used everywhere. Okay, so this is typically a PEB building. So this is typically a PEB building. Okay, so this is a multi-story building. Okay, so we are using for everything. Okay, commercial offices, industrial and processing units, power plant, power and energy sites, warehouses, car parking, residential, and malls and city centers. Okay, we have some idea. Our Indian people are having some idea about this, but we are not very familiar with this. So in this presentation, I wanted to show how the steel construction is going on here. Okay, see these are all typical steel construction. Okay? The frame. Okay, so the skeletal of the system will be having the steel. Okay, that all the columns will be made of steel. Okay, and then the beams will be made of steel and slab also to certain extent. It's called, or otherwise people will go for composite sections. Okay, composite sections, that is also only for the floor slabs. Okay, not for the other one. Okay, so we have, I will touch upon that. We have the composite columns, we have composite beams, we have steel concrete composite. I'm not talking about the fiber composite, I'm talking about the steel concrete composite. Okay, composite deck slabs. Okay, so this kind of, this type of buildings, okay, there is no wall, all are glass cladding. Okay, you have to create the what is it called, the frame, okay, with a steel. And one more point I just wanted to highlight here, the speed of construction will be very, very high in the steel construction. It is because you are pre-planning everything and then you have to bring it in assemble, that's all. Okay, when you go up, okay, in the upcoming slide I will show that process also. Very, if you are going for like a 50-story building, they can go in 10 stories batches. When they go to the 50th story, the first 20 story can be used. What is the use? The income from the building will start generating. Okay, so that is the advantage. If it is RC, there is no curing period like 28 days. You can keep on work, but whereas in the concrete structures, for every floor they have to wait for minimum 28 days. After the 28 days, only they can go to the next floor. Then you have to wait for 28 days. Then next day, next floor. Okay, like that you have to go for each and every floor. You have to wait for 28 days minimum. Okay, it will take more than that minimum. But here it is not like that. Once you plan properly, it will be that 28 days will be one day maybe. That I'll tell you how that one day, then how fast it is, how we are permitting the earlier occupancy. What is the advantage of earlier occupancy? So the return. Okay, say for example, if you are doing something in Chennai, Mount Road or whatever, 50 rupees per square feet rental income. If you are developing 1 lakh floor area of 1 lakh square feet, okay, you just imagine, okay, so 50 lakhs income will be there for one floor. So 10 floor, okay, 5 crore income when you are doing the building in the rest of the area. So that is an advantage. Okay, so you are reducing 28 days. So when you are going for 50-story building, so just how many days you are reducing, how you are applying the earlier occupancy. These are all possible in steel construction. Okay, and so these are all the typical buildings nowadays. The modern buildings they are using. Okay, you can see here the steel frames. Okay, and also this is another important structure I wanted to show. When it is subjected to heavy wind load and cyclonic load, tornado sort of thing. If it is a rectangular frame, it will attract more forces. Okay, and therefore, if it is this kind of curved surfaces, the wind force will get reduced. For that reason, now people are going for curved surfaces on this. These are all possible in this steel construction. Okay, these are all possible in the steel construction. Okay, even this is called the aerodynamic design. In the aerodynamic design, even for small cars, aircrafts, and everything is designed for aerodynamic. Even if you see the bullet train and our train, the bullet train shape will be something different. Not only the shape, the surface should be smooth so that the air will get distracted. Okay, if it is rough, definitely it will attract more force. It depends upon the roughness, the surface roughness as well as the geometry. Okay, so these are all the advantage. Okay, you can see here. This is China's television corporate office. You see, two things are in two different directions, and at the top, they have the L-shaped connection. L-shaped. Definitely, a lot of the steel construction provide more flexibility. Okay, so because of its own merits. Okay, and lightweight and high strength. Okay, and it can be assembled and it can be joined together. Okay, so these are all the thing. Okay, so this is MRT station. You just imagine this is a MRT station. Okay, these are all in China. Okay, so we can see a lot of wonderful structures there. You just imagine. This is totally lightweight. Totally lightweight. There is no need for lighting. There is no need for only during nighttime you need. Okay, daytime you don't need to go for lighting. And similarly, airflow will be there. Everything. Okay, perfect. Even if it is seismic, the total mass will be less. Okay, so of course, this twin tower, we have the steel concrete composite columns and the steel concrete composite slab and the steel concrete composite beam all together, steel and concrete composite, very faster construction. Okay, and now when you go for this, we have the castellated beam. Even if you have the beams, the beams with web opening. Okay, a lot of researchers are going on this beams with web opening. Okay, why we wanted to go for this? Sometimes the load will be less, but the span will be more. Okay, in that cases, we need some moment of inertia to limit the deflection and that. But if you are increasing the moment of inertia, the section size will go up, but that section size utility ratio will be very, very less. Okay, utility ratio means it is very much underutilized. So in that sense, what will happen? We are when anything is underutilized, we are wasting the material. Okay, so for that reason, people are going for castellated beam. This castellated beam, it is not simply creating a hole. It is a special process. Okay, and a 150 mm beam can be made into 300 mm beam. So 300 mm castellated beam. Then this weight and that weight is the same for a given span. Okay, but it will solve the purpose. That's called the castellated beam. Okay, it is not taking a beam and making a hole. No, it is not like that. So there is a special process, and they will make. You assume there is a ISMB 150. That ISMB 150 can be made maximum of ISMB closer to 300, not exactly 300, closer to 300. So we can increase the depth. Okay, so they will cut the web and then they will slightly zigzag it and then they will weld it again. So this will solve a lot of issues. Why? Because it will reduce the self-weight of the system. It will fulfill the requirements. Okay, and a lot of researches are also going on in castellated beams. Okay, and people can think about castellated. But one thing I wanted to tell you, in the developed nation, everything is experimented. Okay, everything is done and a lot of procedures are there. Okay, but in countries like our own, so we are trying to, because this type of constructions, it is not popular here. So we wanted to do for our own conditions. Okay, that we can do. Okay, and yeah, in steel construction, okay, nowadays we are using only RCC, but typically here and all you can see the steel. Okay, see, this is again yeah, the London 9. Okay, it is connected with all the spokes here. Okay, all tension member, and it is there. It's pure steel construction. So ultimately, what when you talk about, you see the next building and you see the diameter roughly, and it is like almost like a 30-40 story building, and that will become the radius, and then you imagine this, okay, size of this, okay, and what is happening? What are these? Something is attached. If you go closer to that, it will be like this, and you can see here inside so many people are, okay, and they can see the entire city from there. Okay, so now the design, okay. So basically, when we come to the, I told you at the beginning, elements. When you take any element, what are the different possible loads can occur? What are the different failure modes can occur? How the mode of failure can be modified? Okay, so how the structural system can be adjusted to take care of the failure modes, and how the structural systems. Okay, what are the different configurations? Okay, I'm talking in general, but there are so many things. Okay, with respect to material, with respect to geometry, with respect to connection, with respect to forces, with so many, and that is the reason why still there are so much amount of research is going on in this type of the ball joints. Okay, the fatigue behavior. These elements will be subjected to huge fatigue behavior, fracture mechanics, crack propagation. There are plenty of opportunities are there in the. That's why worldwide many people are working in this kind of area. Okay, so you just imagine, many of you might have gone through the roller coaster. Do you think roller coaster, the elements are so simple? It is not so. Okay, see, one thing is, we can, whenever we don't know much, we can do conservative side. But if you want to optimize, then we have to go for the research. Understand? So conservatively, we can do whatever we want. At the moment, this is what happens in the design. Okay, if you don't know much on the technology side, then we will do on conservative side. Still, it will solve the purpose. Whereas, if you want to optimize, then you have to go for research problems. There is a scope for, this will be also subjected to dynamic load, fatigue load, okay, traction load, so many loads. So as an engineer, we have to see all these things. Okay, there are, see, this is one part of deck in a ship, barge. People can park and they can sit in the first floor. They can go to the other side. They can come back to the car. They can take out the car and they can go to the island. Okay, so this is full of made with the steel construction. This is a floating structure. Okay, now again it is subjected to varying changing loads. Okay, so like that, we can do a research in the connections. Okay, in the changing locations of the loads and so on. Okay, this is what happens worldwide. Okay, so I just wanted to highlight certain things. Okay, I think now my time is up. I'll quickly rush through. And of course, many of you might have seen in the internet, this called the Golden Gate Bridge. Okay, see, it's a suspension bridge. If you connect with the tensile member, and you see how much amount of everything is subjected to fatigue. And throughout the lifespan, what is the corrosion influence and how that it will reduce that area, and what is that ambient condition, what is that environmental condition, how the corrosion will, what is the protection we have to give. So each and every point is having the research aspect. Each and every point is having the research aspect. So this is what we should try to understand. Okay, of course, this is also in Malaysia, so I don't want to touch upon all these things. Okay, so this is our own Rameshwaram bridge. Just imagine this will open and close. Okay, of course. Okay, there are huge research to be. So far, this is only one bridge available in India. Okay, people can think about it. See, this is called the box girders. It is subjected to moving load, and so many components are there. This box girder subjected to moving load. It's a monorail. We call it as monorail, single rail. Okay, so it is moving. You just imagine. See, ultimately, what is the research? What are the failures it can happen? What is the failure mode it can go? And how we can address the failure modes. Okay, so that's what we should think. We can simulate, we can do. Okay, so ultimately, you just see this is one of the Olympic stadium in China. Okay, so this is the name itself called the bird's nest. I'll tell you why they call it as bird's nest. The steel construction and the bird's nest, there is a close relation. Okay, so your elements must be properly placed, and your bracing elements should be properly placed like a bird's nest. Okay, so that's a very important thing. And of course, this is another big area where a lot of work is going on in the research side also. This is called offshore oil and gas jackets. Okay, so jacket and platform. Okay, so it will be inside the ocean. Okay, the entire units will be fabricated in the ground, and then it will be taken to that particular site and it will be installed. Okay, huge work is there. Okay, so some of the photos, for example, this project and this project, I was also involved in certain aspects. Okay, and this is how they will fabricate, and then they will. I don't have much time to discuss all those things. So these are all the typical fabrication, and then it will be loaded in a box, and it will be traveling to the particular site. And there are some during travel, some displacement modes like rolling, pitching, heaving, and all those things will be there. And these are all the people, those who are involved in transporting from one end to the other end: marine fasteners, marine warranty surveyor, loading and barge, dynamic positioning. This dynamic positioning, ballasting. So many aspects are there. There are opportunities to do research as well as working for civil engineers. Okay, so this is typical construction site. You see the man size and the pipe size. So very huge. Okay, so this is typical one particular the product area like this. This rectangular cells are one platform. Okay, so many platforms in the Southeast Asia, in the Singapore, Malaysia, Vietnam, Cambodia, in that region, we have plenty of oil fields like this. This is one field, to be frank. Okay, in the one field, we have so many platforms, and the lines are the pipelines connected. If you go in the night time in a closer altitude by helicopter or whatever, you can see a lot of lights like a city. Okay, so it is like that. And see, this is my own project. Okay, in steel, one of the structure got failed. So, and myself and another person was involved in this project. We have done the fracture mechanics study here. I did the stress analysis and for a particular joint, and I gave that result to that person. He did the what is it called, the fracture mechanics analysis, and it's a very large dimensions. You can't imagine. Okay, this plate is like 500 mm thick by 1.5 meter long, something like that. 500 mm thick. So you can't imagine. Okay, so the sizes are very big. And this is when I was working in Singapore, I did this model. Okay, so these are all the stress contours. We try to get the open stress and closing stress. And if you are giving a crack in the particular crack means the weld defect. If you are modeling the weld defect, and when it is subjected to opening and closing stresses, how it goes. Okay, so like this, how it goes. Okay, so it's all very challenging. A lot of things can be done. Okay, so this is another interesting project I was involved in when I was working in Singapore. Okay, you need a lot of uh, passion towards the entire system was developed by our team. Okay, so it was quite interesting. It is a challenging project. Actually, there is a pipeline here. Here, it was damaged. It was 45 meters below the water depth, and they wanted to repair this during operation. This is a 36-inch diameter pipe, and it is at 45-meter depth, and it should be repaired without stopping the process. And the water welding is there. That welding also not permitted, and we wanted to do some cover. Okay, this analysis and all I have done. Okay, these are all my finite element modeling, and this development I have done. This is actually the what is it called, the it's like a double sleeve, and the end also we have put a sleeve. It's a tightening, into bolt tightening systems. Okay, everything we simulated in the tank. Okay, so these are all research-based projects. Okay, we have done a lot of work. We have done, it is like a 1-year project actually. This is a final product. Then finally it got to a site. Okay, and it was installed. Okay, so this is a model piece. Another piece was fabricated and went to the site. Okay, so a lot of things, nowadays, for small buildings we are going for cold form steel, and that's the reason why cold form steel, there are so many researchers are going on cold form steel. We are just replacing the wooden planks. Okay. You can see here we are just replacing the wooden planks. Okay, and now okay, so this is what I told, how we are doing the steel construction for high-rise building. Basically, we will be taking care of the lateral load. We have to split the load into two systems: so lateral load system and gravity load system. The lateral load system will be made with the shear wall or something like that. Then the gravity load system, it will be subjected only to vertical gravity loads. Okay, this is what I told. Okay, and this is your shear wall system, and it will be connected with all the gravity loads. These elements will be subjected to only gravity loads. Okay, that's why we are doing a lot of testing for axially loaded column. Okay, this is actually your composite column. Okay, the concrete infilled steel tubes. Okay, concrete infilled steel tubes, and a lot of researchers are going on in this particular direction. And these are all the beams connected with the steel concrete composite columns. Okay, and then the beams will be provided the shear connector to make the beam as a shear concrete beam. Okay, so floor will be looking like this, and the beams with the shear connector. See, now this will act as a reinforcement as well as the bottom plate. Okay, it will be like this. You can see here the plates, the beams, and then there's a plate. Okay, corrugated sheets. The corrugated sheets will be in the range of 6 mm, and that will act as a reinforcement and also a former. Okay, that's the advantage. Okay, there is no rebar, cutting, bending, glazing, cover concrete, nothing like that. There is no former. We just put the sheets and pour the concrete. That's all. You can go to the next level. We need not wait for curing. That is what I told. Okay, we can do faster construction. Okay, see, next day you pour the concrete. Okay, one fellow will keep on do this. Okay, they will keep on go up. Somebody will do the slip-form construction. They will go for this, and then somebody will go for this, and somebody will tie all this, and somebody will do the sheets, and somebody will pump. Okay, it is a routine procedure. Every day one floor they can make. Every day one floor they can make. Okay, so this is the way they do. Okay, this was constructed in Singapore when we were there. Okay, this is the core one. Okay, and see, whatever the points I'm saying, everywhere a lot of research opportunities are there. Say, for example, shear wall systems, steel columns and steel beams, composite floor slab. If you go through the Journal of Structural Engineering or whatever, everywhere so many works are going on in these particular directions. Okay, so this is our own project in NIT Trichy, long span. I just wanted to show you a very long span, large, 50-meter span by 100-meter hall, 5,000 seating capacity, 50-meter span. Okay, so I know many of the participants are M.Tech structures or lecturers and professors like that. 50-meter RCC, it is very difficult. Okay, whereas steel construction we can go for. This is also called PEV structure. Okay, 50-meter means RCC, it is not at all possible. Even presses also not possible. So it will be very, very heavy sections. But whereas here we can go for very thinner section, lightweight structure, and very efficient system. Okay, so this is the final product. It is in Ertce. Okay, our own building. Okay, so like that you can make many systems. Okay, and of course now I'm rushing, and this is my latest one of my projects. I did the structural vetting. Okay, it's very interesting project. Here we have 2 floors actually. Here we have 2 floors, and here we have 2 floors. Here in each tower we have 2 floors, and inside there is a lift and all. People can go. You can see here. This is at the construction stage. Okay, so this is the construction stage here. This is the final product actually. These 2 floors are covered. They have restaurant, everything. It is in Hyderabad, and I was also involved in the structural, vetting process. I was the person approved these drawings. Okay, so things are like that. You can do whatever the challenge you can do with the steel construction, and of course you have to do a lot of research. Okay, so this is a question I just wanted to ask. Things will happen like this also in steel. Okay, okay. So this is another important thing. If you are not okay, if you are not good at assembling the element, that's why I told this is like a bird's nest. If it is not properly connected, these things will happen. Okay, if people can study about the block shear and all. Now we can see the reality. These things, I have taken this photo in Nagapattinam area when the Gaja cyclone was hit at this area. Okay, the real, whatever the failure mode you study in steel construction, you can see here, tearing, block shear, everything. Okay, shearing of the bolt, okay, foundation shear bolt, okay, shear failure. You can see very interesting failures. Okay, so things can happen. Only thing you should understand. Okay, so you have to put a lot of bracing elements. You have to transfer the loads properly. Then it will be very good structural system. Okay, and in that sense only things are going. Okay? And therefore a lot of researches are also going on. Okay, I think I don't have much time. Dr. Nisha Radhakrishnan madam is here. I will stop here. Okay. If there is any question, you can ask.
Dr. Bhaskar sir.
Yes, sir.
Quantum of information.
No, I'm not able to hear you. Your voice is so low.
The quantum of information.
Okay.
Now you are audible. I'm clear, sir. For you?
Yeah.
Very interesting area you have presented, sir.
Okay.
The quantum of information, what you have shared related to the steel structure. Of course, the undergraduate students are studying steel structural engineering 192. So your knowledge sharing is helping our students to get more innovations in the field of civil engineering. The pictures which you have highlighted are amazing. That shows that how much dream you have in your mind to build up the adventures in the field of steel structures. There is no limit for your knowledge. Sky is only the limit for your knowledge. Really, very good presentation. We are proud of you. Sairam is thanking you, sir. Let us meet once again in future with some other golden opportunities.
Sure,
God
sir. Thank you,
sir.
Thank you all. Bye. Bye, sir.
Thank you, sir.
Let us someone.
Dr. Nisha Radhakrishnan, madam.
Good afternoon, sir.
Good afternoon. Sukham ano?
Oh, Sukham, sir. Yeah.
Right. And today, our another keynote speaker, Dr. Radhakrishnan, graduated from IIT Madras. Already, madam is having a very close relationship with the Sairam Engineering College. In the previous year also, madam shared her knowledge through online. And this is the platform which Sairam Engineering College is promoting in international level. And Today morning, this is the last section shared by Dr. Vishal Radhakrishnan. Very talented faculty. Because of her hard work, smartness, innovation, creativity, thinking, Madam completed her PhD in IIT Madras and attained a faculty position as a professor in National Institute of Technology, Tiruchirappalli. Madam, we are so delighted by seeing you. We are so honored by getting your knowledge. Now the platform is to you, madam. Please take over the section. Actually, 30 minutes is allotted. You can try to finish it at 1 or before 1:15, madam.
Yeah, sure, sir. Sure.
Yeah, thank you.
Okay. Good afternoon, one and all. First of all, thank you for this opportunity. Second time to be a part of your program. And since we are short of time, I will try to finish it within 30 minutes or so. So what I'm trying to mention here is the application of surveying, like in civil engineering. Now we learn in our UG, usually we have surveying 1, surveying 2 and all that. So surveying 1, we deal with chain, compass and all that. But then when we go practically into the field, these equipments don't come into use. That's when we go in for advanced surveying techniques. So on the commercial side or from the research or project side, people usually will go only for advanced surveying techniques. So my whole presentation would try to give you some idea about what these tools are, what are their uses, and how you can put up in applications. Applications are abundant, but I will just mention maybe 2 or 3 applications so that you will get an idea of where it can be utilized. Okay. Now, the $1 million question is why we are going for these techniques. And there are different names. We have geoinformatics, some call it as remote sensing GIS, advanced surveying and all that. But why we require it in civil engineering? Now, the need for this kind of a technique, or from the research side and also from the implementation side, it came mostly because of our urban growth. Now, in India, the growth is happening very, very fast. And you have no idea where it is growing. It could be planned, it would be unplanned. And if it is unplanned, it is chaos. So we have to develop methodologies to make sure that the development is proper and planning. Now, where do we do this planning? The first planning would be from surveying. Okay. And when a technology gets attached to it, then it becomes advanced surveying. Now, things are all digital. You have smartphones, you have smart computers. So without tech, it makes our life very, very easy. So we need to look for a technology where you get the answer very, very fast. So that's where the conceptualization of these techniques came in. Now, urban cities in growth in cities. Now, we know that cities are major hubs for all human activities and they play a major role for economic growth. But as I said, in India, these changes are happening so drastically that you have no idea where the change has taken place. So when that happens, what happens? Urbanization. It's a global phenomena where you have unprecedented growth and you have migration from rural areas and smaller towns to cities. In search of job, ultimately you will also plan to go either to Bangalore or Chennai and all that. So that's a mindset of ours, that we need to go to places where we can grow. But in that thing of we can grow, the city is growing in a different way. And what happens when the city grows in a different way? It gets squeezed to become unplanned growth. And unplanned growth for future is not good at all. So there's a very simple methodology. Because of this growth, are there any problems? So the first thing is identify whether there is a problem. Now, if there is a problem, how do you solve it? When you start solving the problem, you will see there are many constraints. So how do you identify those constraints? And then once you have identified the constraints, removed those constraints, we need a solution. And how do we develop a solution? That is where we as researchers or academicians come into being. So we need to develop, we need to improvise, we need to look for new techniques which will allow you to solve the problem. Right. So urbanization, as I was mentioning it to you, it is poor development, unplanned growth, resulting in unplanned developmental activities. It has got poor infrastructural facilities, urban sprawl, congestion. You may have seen when you're traveling in cities itself. In cities, so once a place is very nicely developed and some places are poorly developed. Now, we really think why one side is good and the other side is not developed properly. That is because it is not planned properly. Wherever people feel that they need to develop, they will develop it, but they leave aside the other place. And in future, those kind of things become problematic for development. Okay. So in developing countries like India, these factors will hinder the scope for development in future. So how do we correct it? We have to assess those changes. What happened in the past? What is happening now? These two things has to be studied. They have to be compared. And then you decide what you require for the future. So in India, there are many constraints. And the constraint starts with data. There is, when you start doing such kind of work, you will find it is very difficult to get data. The data may be incomplete. There may be unavailability of data. Fund is a problem. Then traditional methods like chain, compass, theodolite, those things are available, but other things are not available. Large data, if it is available, it is uncoordinated. You don't know where it is. Information is not updated. Information must be some 20 years to 40 years old. But current information is not available. It's not updated. So these are the constraints. So these constraints can be removed when you go for digital information. So that's where advanced surveying comes into being. So in order to tackle all these problems, this new concept has come. Now it is not new, but things have started modifying. Now in the past 10 years to 15 years, many changes have happened in surveying. Of course, in the UG level, you will be learning basics, because basics is what is the mother of all these advanced surveying techniques. That fundamental is put into advanced surveying, that's all. But it makes your methodology much more stronger when it comes to project development. Okay. So like I said, there are different names. You have advanced surveying, geoinformatics, geospatial, all those things are there. Then there is one more thing which we prefer to use when we do from project level. We call it as 3S technology. Those are S from remote sensing, the S from GIS, and S from GPS, because these three are the main advanced surveying techniques. Of course, now you have drones, but drones has its own limitation now as per government norms. Without permission and also without certified license, you cannot use drones for these kind of purposes. So still, the entire thing is limited to remote sensing, GIS, and GPS. Now, all this you are quite aware what is the definition of surveying and all that. I will not get into it. But what I would want to specify is these techniques. I prefer to divide it into two. The equipments where you understand the fundamentals, which you learn in your UG level. They are chain, compass, theodolite level and all. Then advanced equipments which make use of electronics and other techniques, we can put it under the advanced surveying techniques. Like you have EDMs, total stations, remote sensing, GPS, drones, lidars. These are all coming under advanced surveying techniques. All this you are quite aware, chain, theodolite, dumpy level, plane table and all that. Now these equipments, though they are important, they are very important from academic point of view, yes, and for small scale works. But when you do a vast area work, these equipments have their own disadvantages. So the main disadvantage is the amount of work that you can do with these equipment is limited. You can study only small areas. Then intervisibility is mandatory. If there are two people on two sides of a chain, the person from one side should be visible to the other person. So the equipments have to be visible. Then you cannot use it in the night time. If it starts raining, you have to stop the work. Then you require a lot of people. For a chain itself, you need 2 people. To carry it itself, it takes a lot of time. Then for theodolite, you need 1 person. For tripod, then for theodolite, then you need to carry tape or chain, then other accessories. You require a lot of people to work. Then for us, time is very important now. So the entire conventional surveying is very, very time consuming. You cannot think of finishing the work in one day. Budget is limited. You have to think where you can cut short finances. Then most important thing is that surveying means coordinates. All of us know what is Google Map, what is Google Earth. In Google Map and Google Earth, the coordinates is latitude, longitude, and height. So there are 3 things. These 3 things tells you your position. How your mobile phone will tell you where you are, right? That is because it tells you lat, long, and height. None of the conventional equipments will give you 3-dimensional observations in one go. You have to carry 2-3 equipments together, then you will get 3D. So that's where the hurdle is. Too many equipments, too many calculations, too many methods. We need an equipment which will give us the answer then and then. 3D, no calculation involved. That is what our idea is. Then other problem in conventional equipment is it is manual entry. You write it by hand. Now we've seen students when they write today, they will write 3. Then within 5 minutes, maybe they will overwrite it as 5. Then next week, they will open the book. They will have no idea whether it is 3 or 5. So that's manual entry. A lot of scratching, cutting, and all those things. So this manual entry will cause error. Then there are a lot of manual calculations involved. And we see batches of students. Some of them are comfortable with 2 decimal places. Some of them are comfortable with 3. Some with no. So each batch will have different decimals. When you club everything together, the answer is a chaotic. There will be error in whatever calculations that you do. So that's the thing. Manual calculation is involved, less precise, less accurate, and there is no storage. So next, after a week or 10, after like I take a data today, if I want the same data after 10 to 20 years, it's not stored anywhere. It must be in some hard paper and I don't know where I have thrown it or where I have dumped it. I have no idea. So that retrieval capability is not there in conventional surveying. That's one of the major constraints when it comes to some government offices. It's very difficult to get the data. The data is available, but we don't know where it is lying. So that's where we require digital information. Digital means you can store it somewhere for as many number of years as possible. So to overcome all these limitations, you have these number of equipments, which has made surveying quite easy. But then there is a catch. These things are not cheap, they're expensive. But the initial expenses, we can take care. After that, you can even generate out a lot of revenue from these equipments by doing some kind of a research or some kind of consultancies and all that. So these equipments are going to be there and you can use it for many applications. So removing out some of these things, so intervisibility is not required. You can use it at any time of the day. Then all the data is automatic, so it is digital. There's no writing. Then storing and retrieving is possible. Large amount of data can be collected. It is less time consuming. You can download the data. Then there is no calculation involved, in the sense that you are not automatically, manually you are not calculating anything. The calculation is done by the equipment itself. So all these equipments have their own processor. So whatever fundamentals you learn in surveying, it is put it into the processor in the form of a software. So the software will take care of the calculation. So once you fix up the equipment and start taking the reading, it will give you the answer on the screen itself. You can download it. You will get the lat, long, and height immediately, just like that. So 3D measurements is possible. Okay. Now this, I'm sure many of you would have seen. This is a simple total station. an electronics total station. And if you see here on the screen, you will get the latitude, the horizontal angle, vertical angle, and also the distance. So you fix the equipment somewhere, and from the equipment, one laser beam will come out. It will strike the object. From there, you will get all these answers. So that's principles of electronics. And you can't think of this simple kind of a thing if you're making use of a theodolite. I'm sure all of you would have used a theodolite, and you know how difficult it is to first fix up the theodolite, then keep the ranging rod somewhere, sight that ranging rod, make sure all the crosshairs are visible, make sure that it is vertical. All those issues are there. In these equipments, the reading you will only be visible on the screen if you have leveled the equipment properly. Otherwise, this equipment will not work. It will be a dummy there. These equipments will help you to level it properly. It will help you in how to take the data. Like I'm showing you a beam here. If there is an obstruction near the beam, you will not get an answer on the screen as it is here. So this makes your work much more simple. Okay. Now there are different companies which are coming up with different theodolites. Some of the companies are like this: Pentax, Sophia, Trimble. Trimble is an equipment which makes use of GIS also now. So all the data will be stored in a GIS platform within the equipment itself. You can download it. Then you have Wi-Fi, Bluetooth, GPS, everything is available in the current total stations that are present. Okay. Then in your surveying, I'm sure many of you must have learned single plane method, double plane method, and all that to find out height of a building. I'm sure all of you would have understood that you need to have two equipments, you need to fix up the point somewhere, target and all that. And there are some calculations like D is equal to beta and theta, S tan and alpha and all that, right? Now here, all that headache is not there. You just have to fix up the equipment, sight whichever point you require, send that beam when it will come back to the equipment, you will get your answer. So the height, the distance, the angle, everything will be available on the screen. You can either note it down or you can even save it in one file and then download it in the near future whenever you feel like downloading it. So that's total station. So you can see on the screen, you have horizontal distance. This is the vertical distance and this is, angle, and this is the distance. So the entire answer is here. You don't have to sit and count the number of divisions in the theodolite. You don't have to read vernier A or vernier B. You don't have to run a tape, nothing of that sort. So everything is available on the screen. Then you have digital level. This is an advanced form of dumpy level. And again here, electronics is involved. The equipment will send out a laser beam. The laser beam will give you the reduced level. So a main idea is like when you do level, you have to take a staff reading, then you have to add it with the RL, and then you will get your reduced level. Yeah, everything will be done by the equipment itself. You don't have to sit and calculate or draw tables like HI, which is backside, which is foresight, which is the intermediate side and all that. Everything the equipment will understand. You fix the equipment will understand the first reading is backside. It will tag it like that. The next moment when you shift the equipment will understand that that is the foresight. And if you want to shift the equipment, you can train the equipment saying, okay, I'm planning to shift the equipment. When I shift it, the last foresight will automatically become my backside. And it will calculate on its own as you move forward. So this is the way things have advanced so that your work becomes much, much faster. So those things which you feel you can finish it in 1 month using conventional equipments, now that will come down to 10 to 10 days. So that's the speed with which you can work now. So that's the thing. Okay. Then one of the major thing which we are using in day-to-day life. Now all of you in your mobile phone are using Google Maps. Many of us are using Google Earth. Google Map is one major example of a combination of remote sensing, GIS, and GPS. I'm sure none of you would have wondered, how are we able to locate which place we want to go, the direction. Like here there'll be one circle when you open Google Map that this is your position. You will enter, I want to go to so and so place. It will calculate which direction you should go. Now, how do you think this has come up? It is because of these three things. These three things, along with computer science or software development involved, has given you your Google Map. So you should understand that many of the things that nowadays are used are because of surveyors and civil engineers. So Google app, okay, it's a software person would do it, but the basic behind it, the fundamental behind it, the images behind it, all that is surveying, or all that is civil engineering application. So that's a kind of a scope. So many software companies have this particular division also for digital thing, like remote sensing or geomatics and all that. They have a separate wing. Like TC has one TCS GIS. So that's where they do all these kind of applications studies. Okay, so remote sensing is a technology where you get to study the earth in a larger view. The moment you open your eye, you are seeing a lot of things in the earth. Okay, like, and now you're looking at the screen. And when you look in the morning, your eye is telling you, okay, the sun is bright, it is very, the clothes are, the tree is green in color, this and that and all that. But why is it possible? Because you are surveying the application, you're surveying your environment. And this surveying the environment is what is called remote sensing. Okay, so remote sensing is a technology where you are able to view a large area of the earth. You get a 3D, then many things that are not visible to the human eye also can be seen using remote sensing. Then it gives you a permanent record of the object. The best remote sensing application or example is your human eye. That's, you are trying to remotely study an object without touching it. That is a basic definition of remote sensing. But the problem with eye is that every time I move my eye, whatever image got registered for every movement, it gets erased out. Then it becomes a small memory, if the memory is worth being remembered. Whereas remote sensing is, it is a permanent record. Where it's available, you can use it after 10 years, 15 years, 20 years and all that. So you get a permanent record of whatever you're seeing. That's what is called remote sensing. And the data is real time, it is repetitive and all. Now, we know this is a basket of fruits. Now, how do we know it is a basket? How do we know it is a basket of fruit? Because our brain has a database. And that database understands color, understands shape, and understands not many other things. And based on that, it will tell what is on the screen. Now, I know there is grapes. I know there is apple. I know there is banana. I know there is orange and all that. Okay, so that is how my brain has got asserted. Now, remote sensing doesn't tell you only this. The remote sensing person will try to judge by just looking at the basket of fruit, whether that fruit is ripe or not. Then whether that, I'm not touching the screen at all. There's nothing. I'm not even touching the fruit. So just by looking at this idea of what my brain is able to understand, I can tell lot many things and I'm able to identify lot many things, right? So that's what is called remote sensing. Identifying the characteristics of the object on the screen without touching it. That is what we use when we do analysis in a larger scale. Now, this is a small scale thing. As a civil engineer, what a person does. Suppose I am giving you a task to do city planning, like Chennai. I want to do Chennai entire mapping. I want to do the entire Chennai mapping. Chennai is a very vast city. And then there are so many roads, there are many buildings, there is a lot of vegetation around, there are a lot of water bodies around. So these are each items that are pointing out. I want to give, if I give you a task to do this mapping for the entire city, having roads, buildings, then vegetation, if there is forest, water bodies, again in water bodies, there are different type of water bodies, roads, there are different type of roads, buildings, there are different type of buildings. Manually, you cannot think of doing this in 5 years. You cannot finish it at all. So a lot of factors are involved. That is when remote sensing comes into use. So remote sensing will give you a picture like this. Now here I am showing you Ertce city. This is a kind of a remote sensing image. So once I get an image like this, I can study what is happening in the city. I can find out what is the percentage of greenery around. This is the Kaveri bed. So what is the shape of the Kaveri bed? Is there water there? If there is water, how much is the water? So remote sensing images will have coordinates on it. So if I'm moving my mouse, it should tell me the coordinates. And I can find out how much of stretch of a river is having water. I can keep my mouse here. Now this is a JPEG file, so here it's not possible. You can try out in Google Earth. There is a thing in Google Earth. You can find out what is the distance from one stretch of this riverbed to the other type stretch of the riverbed. You can find out the distance. Likewise, if this is in urban activity, I can find out how much area of urban activity is present. Manually, it will take ages for you to finish. But here now, sitting in the office, if you have an image like this, and I have suitable software, I can do this analysis. I can find out how much percentage is urban activity, how much percentage is vegetation, how much percentage is water body. Like that, if I zoom in, I'll get more and more details. I have agriculture here. How much is agriculture? What is the size of this agriculture plot? Then I can see roads. So I can find out the length of the road. All that, if you're doing it on the field, going manually, it will take a lot of time. You can do it, but it will take a lot of time. So more and more when I go in, I'll get more and more information. Individually, it's not possible for you to visit each and every house and get the data. Whereas here you can get the information possible. You will get all the coordinates and all that. So this is one application of urban planning. Then you can see Sri Rangam. What is the development of Sri Rangam? The temple. You see what is the activity going around Sri Rangam. If you want to build a house somewhere, you can find out which area is vacant from this. So that way you can think of many applications. This is Malakotai. This is another temple which is very near to NIT campus. You can see the growth. So this kind of a growth you can only anticipate or understand when you're looking it from the top. So this is a remote sensing image. So this is the Ertce airport. You can see the runway. There's agricultural land. Then you can see the development. All that. So the site distance, the site growth, the runway development, all that is analyzed based on what is happening on either side of the runway. This is another central bus stand in Ertce. You can see the roads. So if you want to do further development based on traffic, you can make use of these kind of images also. Okay, so those are images which can tell you what is exactly happening. So that is one set of data that you have where you can work with. Now, that's an image. Now, this image, you have to put it into a software which is called GIS. Now, this GIS will give you a means by which you can build answers very easily. Okay, it's just a digital form of maps. And GIS is it's a digital data. So digital data means you can update it, you can delete it, you can analyze it. It's just coding and all those things involved. So it's it, instead of having paper around you, you can have everything in the computer. So that's a GIS. It's a computer system which will allow you to store, acquire, analyze, and display the data. So this is how it is. Reality will be having everything together. Okay, all of you must have seen maps. The maps has all the data together. But GIS can allow me to create different maps for each feature. I can have a separate street map. I can have a separate building map. All that I can digitally prepare. And then I can even share the information from one computer to the other computer. So this is how the thing is. You are converting your world around you to computers. So these are some of the applications in GIS. If you have a data, You can even cut out what is required. This is Trichy City Corporation. I can extract the boundary. Then I can even cut out roads. So we call it as digitization. That is, I can separate out the roads from the image. I can separate out small sections and study it separately. I don't have to study the entire Trichy city. I can even subdivide it and do the analysis. Then I can extract out all these things. I can give different colors if I want. So if I give different colors, I can do analysis much easily. Like black and white, you can't get any idea. But here, if you give a color, I'll know this much percentage is commercial, this much is educational, other is all that. In addition to that, you will get a tabular form also. So there'll be two things. One is you can get it in Excel format, and then also you will get it in a color format. So this gives you more value added answers. So if you want to present it to somebody, if you have this table and the picture, you can convince your corporation people much simpler. Now all this manually you cannot do. Manually you have to sit and draw by hand. Then you have to do scaling, all those things. It takes a lot of time. Whereas here you will get it very beautifully. Then GPS is used for getting coordinates. So like how your mobile phone, latitude, longitude, and height, that's one thing. Google Map is an entire example of combination of these three technologies. There are many GPS equipments. One good example is now your mobile phone itself. Then different applications will have different GPS. Ola, again, that app works on your GPS only. Then these are different varieties of GPS based on application. Then there are GIS also involved in this. So there are some good examples where GIS and GPS have been used. This is one example where you have using just this yellow color equipment, this one particular handled equipment, and GIS, the entire map of IIT Bombay was prepared. Now, this was prepared in the year 2000-2001 by some BTech students at that time. You can see the details in which it has been done. So this, they did it within a few days or I think maybe weeks. But when you're doing this manually, you will not get this much kind of a precision involved, or even this kind of detailing, drawing and all that. It's impossible. This is one very good example where you can make use of these applications. Then some applications in urban planning, I'll try to move faster, where remote sensing can be used. So this is one project which we had undertaken for Trichy Corporation, where the images of different years were selected and the growth of the Trichy city was tried to analyze, just to know whether the growth is planned or unplanned. So there are images which you can purchase from government organizations, and then from that the analysis is done. So all these images are black and white. Now looking at the black and white image, you won't know what it is. So once you extract, you have to study the area. Okay. Once you know what is the area, you can give your own color code. So this is the original image. Now it's a photograph. Every photograph is made up of pixels. So there are small pixels. And this pixel will have one color in it. Okay, that color will tell you what the object is. Like for us, our mind says that green means it is vegetation. Then yellow means it is this vegetation. Red, we put it as building. So likewise, each pixel, if you give a code, it will give this kind of a variation. And each pixel is one area. So it is some square meter. When you say, I want to find out the agricultural area, it will count how many pixels are green. It will multiply it with the size of the pixel. Once you get that, it will automatically give you the area. Now this picture looks very small, but the entire size is 165 square kilometer. So that's the entire Trichy Corporation that is coming in, right? So which is about, let's say 30 to 40 kilometers up and down. So that's the size which I am mentioning. Okay. So once you know this, you can know what percentage of land is available for each feature. Like red is urban area, green is vegetation, then you have purple is for wasteland. Like that, you can know what and all is. Then, if you study for different years, you will know what is increasing, what is decreasing. So, if you look at these images, 2007, 2009, green is reducing, like where, and red is increasing. So red is urban activity. Like that, if you keep on comparing, you can do statistical analysis and inform the government that, okay, agriculture land is coming down. Instead of that, built up land is increasing. Waste land is getting wasted. So once you understand that, you put a tab there. Okay, no more development. If development has to take place, where should it take place? So those kind of statistical analysis you can give the government, and then they can take care of the remaining development. So all this thing is now coming as a part of smart city concepts also. Okay, so once you have understood what is the growth pattern, you can even predict it for the future, that in the future, this much growth will take place. And you can do site suitability analysis. Suppose you want to have a house somewhere. You will look at so many factors. As a lay person, I will look at the surroundings. I will look at the slope. I will look whether the soil is okay or not, whether I'm getting enough groundwater, then the distance from the road and all those things. Okay. If you want it in this fine way, when we do urban planning, if we know what is the growth that is taking place, I will develop a land suitability map. So the land suitability map is these particular factors. I will create map, I will create a model, and that model will tell me that this much of land is available for development. This is moderately suitable, marginally suitable, unsuitable. And also the location of those places, you can also create it in the form of a map. So if I want to build a house, I will look at these red zones. These red zones will tell me, okay, for me it is okay. Then this yellow region is marginally suitable. Then the black portion I should not touch at all. If I fix up a house there, then it is gone case. So those are the kind of things that you can do, corporation people can do, or even you can also do if ever in future you want to think of building up something. Rather than just going here and there, visiting so many places and then building it and then finally observing that, okay, I have made a mistake. So before itself, you can decide what you want to do. Then, even till this thought never comes in our mind that where surveying applications could be used in structures. But in structural engineering also, surveying is important. One thing, for constructing the structure, of course, you have to find out the area of the land and all that. So that's again a survey comes into play. Now there are so many structures. Just a while ago, Dr. Bhaskar had given so many structures. These structures in due course of time will undergo deformation, short term, long term and all that. Now, how do you monitor their deformation? There are many equipments in which surveying can also become a part of it. It is actually a part of structural health monitoring where surveying applications also come into play. So in Jeep, the structural deformation, we use digital photograph to analyze cracks, LIDAR. Then there is GPS also. GPS, it's adopted in many places. In foreign, yes, of course, it is fixed up in almost every high-rise buildings. Then in dams, in India, it is fixed up in Koina Dam. So these places, these GPS equipments can tell you whether the structure is moving way beyond its threshold. Okay. So I'll just move fast here. So this is a structure which is situated in Maharashtra. Now this place is very famous in the sense, it is believed that before the construction of the dam, it was free from earthquakes. But immediately after the fixing, after the dam was constructed, the place is observing a lot of earthquakes, the major one in 1967. But the dam, which stood all that, it is standing still there, but these tremors keep on happening at smaller rates. So many organizations have been involved, and one among them was IIT Bombay, where I itself did my PhD on this. using GPS technology. So there are GPS equipments which you have to continuously monitor on the dam, below the dam and all that. And then the analysis is done. So we know that behind the dam, the water level rises. So how does the dam sway with respect, or how does it respond to the water behind the upstream side? Whether it is, those kind of movements you can analyze. So using GPS, you can know when there is a rise, what is the deformation? If there is a fall in the water, what is the deformation? And you can also understand which direction it is moving. If it is moving in the northeast, southeast, all that again you can analyze using GPS. And if the movement is much way beyond our imagination, then you will know, okay, we have to study this further. So this will give you an idea about what is the movement of the dam. See, everything will be at the surface. So that is a kind of a thing. Then you can even do seismic analysis and study whether the structure is safe or not. It so happened in one of our visits, there was this tremor when we were collecting the data. So we just took the data and analyzed it. And when we collected, we observed that when the earthquake happened, the dam shifted by some centimeters. Okay, so it is 2.3 centimeter, it shifted in this direction, so northwest direction. But immediately after the earthquake, it swayed back again in the opposite direction with the same speed. So based on this amplitude, we observed that the dam is safe. And the similarity in this displacement and their opposite direction told us that the dam is very elastic, and that is the reason why it withstood those major earthquakes and also whatever minor has been taking place in the following years. And then we gave our report, and then even now the tremors are there, but the dam is pretty much safe. So these equipments can also be used as an alternative. I'm not saying that this equipment is the only equipment. No, it can be used along with other equipments as a calibration and validation and all that. Okay. Then there are other applications where you can use site suitability study to know where should be very good educational facilities. Now, this is for Trichy city, where we try to find, based on the existing educational facilities available, we did a study and found out there are certain places which are not having any educational areas. Many kids have to travel a long distances to proper education. So we analyze based on a lot of studies which place is suitable for schools, which is less suitable and all that. Likewise, health facility. If you want to build up a new health facility, which place is the best one, which is having very good demand. Likewise, open spaces, like open spaces in hospitals are a part of smart cities now. So this map can be useful for the study. And this is the end product of the study. There are a lot of things that you have to collect to get this end product, but this end product will be useful in any high level judgment and justification and all that. Okay, you can also do flood risk assessment, like which areas are having high risk of flood, which areas are low risk of flood. So wherever you feel that hazard would be more, you can do proper rehabilitation, proper construction there, proper drainage facilities there. All this thing you can create using a GIS. Then some application of remote sensing in tsunami, like tsunami effect. You can study what happened before tsunami, find out what is the percentage of land already existing in each of the zones, like this much is water body, this much is vegetation, forest. But after tsunami, what happens? You have nothing. But what, as a surveyor, a person should do is they should find out how much a percentage is now available. Compare it what was there before. Then allocate the budget where immediate attention is required. So this pictures and ideas will give you an idea as to how you have to rehabilitate the area. Here also, before, like image is an image. That is not our role. Our role is we have to study this image, find out the percentage of land available for each and everything, before the tsunami, then after the tsunami. Find out which requires immediate attention. So that is what is called disaster management. This is one major application of remote sensing, disaster management. Then before, then after. Whereas before, these many buildings were there before, now there is nothing. So where do I start my disaster management? These images will help you. Okay, so there are many applications. These are some only I have mentioned. You can do many applications, smart cities, ITS, structural deformation, site suitability, photogrammetry. You have now Mars analysis also, where you can study photogrammetry, use photos for studying Mars. Then ISRO is doing a lot of work on remote sensing, all those things. So advanced surveying tools are useful in almost every front. Now it is an interdisciplinary science. It is connected with civil engineering, with instrumentation, with electronics, with earth sciences, physics. Everywhere this thing is there. If you go to foreign universities, it is either connected with civil or it will be with atmospheric sciences. So it's got different names. It has got different applications. As a civil engineer, we mostly look into the application part. An electronics person will look into the digital part, and computer science will look into the software part. So as such, it is an interdisciplinary science, and it has got many applications. It is very economical, it is less time consuming, and many organizations are working on this, from DST to ISRO, NRSA, IIRS, all those. Okay, and these techniques are the revolutionary techniques for the new future. Now, artificial intelligence, all these things are embedded now. Okay. So I think that's it. I try to finish it up in whatever time I have got. So thank you for the opportunity. And over to you, sir.
Michelle, madam.
Yes, sir.
Regarding remote sensing, GIS and GPS, you have clearly explained the need of the day. How the young youth have to upgrade their knowledge to find out the latest technology in the field of advanced surveying. Thank you. Thanks a lot. Let us join once again in future for some other occasions. Thanks.
Thank you. Thank you, sir. Thank you, sir. Okay. See you, sir. Bye.
Thank you for the night. Come back. At the home.
ஒரு 5 நாளைக்கு சார் இங்கேயே தான் விஐபி டைம் பாய் பாய் டக்கிங் நீ வந்துட்டாங்க பாய்
2:15 ஆரம்பிக்க சொல்லுங்க. நான் ஒரு 2:15 வேண்டாம்.
நம்ம
நான் 2 மணிக்கு ஆரம்பிச்சிருங்க. நம்ம ஒரு 30 மினிட்ஸ் விட்டு சொல்லிட்டு ஸ்ரீதர் சார் அவ்வளவுதான்.
Stop.